I'm very happy to introduce Rafael. I think most of you will know him from Technion. Currently, he's doing his sabbatical at the Cambridge University, and he's an expert in BIM and also in digital twins, I guess. So please.
Thanks, that's great. Thanks very much. I guess I'll just begin by thanking the Institute for Advanced Studies, Innovatice and Andre, for the invitation to be here today along with everyone else. Building information modeling I know fairly well. I'm confident. Digital twins a little bit less, but I'm learning fast. Business models I know even less than digital twins, and yet that is my topic. The adoption of innovative technologies in construction. I guess one other thing you ought to know about me as I begin is that I'm a very proud member, as of yesterday, of the Yellow brainstorming group. So what I really would like to do is use the opportunity for the half hour to introduce some of the thinking about how digital twin technology and processes will become adopted in industry. Clearly many of them are already being adopted, but there's a long way to go yet. And not only do we have challenges of how to compile models, how to use them, but especially how to leverage value from them and how to convert that value to monetize it. But there are also aspects of this that we've only just begun to touch. And I think that we've certainly learned that in the construction industry, which is my specialty rather than maintenance operations, there are a lot of concepts from the digital twin ideas that we can apply in construction management itself to make the process much more complete in terms of the cycles, the management cycles. So with that in mind, what I'm going to do is I'm going to try to talk through some of the ideas of innovation in construction and how innovation works within at least the construction field and with a reflection on how that can work in the IT field, working with buildings and assets over the lifetime. A quick introduction, and so really my question or proposition is, can we learn anything from construction tech adoption and extend it to digital twin adoption in commerce? So the starting point here is to recognize this. You can find this in many places. I will show you two charts like this that really tell the story of a very big growth in startup companies in the construction tech area in terms of their numbers and their size. Of course, some of them don't survive. So I learned at lunchtime that Dapri on the left there have already ceased to exist over the last few months. And I guess that many of the others over time will rise and fall. We know that some 90-something% of startup companies do not succeed in the long run. Those that do succeed are often very successful in their own right, but even more commonly are then bought by other companies. So for example, PlanGrid, somewhere here, has already been acquired, and a number of the others as well. You can see the same thing here, construction startup investment, and only the blue numbers go up there, the total dollars invested. The number of deals only goes down in that chart because it was 2018 year to date. I assume that by the end of 2018, that number was higher. Here is another view of pretty much the same thing from a different source, where again, we see that the funding amounts are climbing, the number of deals are climbing. And my experience from Israel, as just one sector, is that we have a very sharp growth of construction tech startups. There are now in Tel Aviv some 40 to 50 of these small companies, anything between 3 to 1 year old, and there are more all the time. What I want to do is give you a sense of how these things develop, both within construction companies or major manufacturing companies in the construction industry, but in particular, I'd like to just try to trace a path from research, academic research, through innovation, through startups, and then into practice, and see some of these things, how they have not quite become reality yet, but are on the way to becoming more familiar. So again, Prescient's a company in manufactured construction of this kind. Instead of simply carrying along and developing things as they might have done in the past, they're beginning to raise capital and to see this as an innovation. So this is quite special, I think, in the construction industry, because we've become used to using these terms, high-tech. Our industry, our economy is largely based on high-tech. It's almost everything. It was once agriculture, but we recognize what we mean when we say high-tech. We also have a sense of what we mean when we say low-tech. And in many places, people have the opinion that what we do is no-tech. and to a large extent that is true. But of course the construction industry is a spectrum, so there are companies which are like this, of course, and there are others which are much more advanced. And that's continuing and growing more and more. And then what's becoming apparent is that there are some specific paths of innovation. Sometimes it will happen within design and construction companies, that somebody will have a good idea, a company will be agile enough to pick up on that and bring it forward as an innovation within the company. Sometimes they're coming from software companies, so there's no doubt that companies such as Nemetschek here in Bavaria, or Autodesk and Bentley, they're all contributing their share to innovations in particular directions. But a lot of times, innovations in those companies are not actually coming from within the companies. They're coming through acquisitions of startup companies who've had some good idea, and then they're being bought by the bigger software company. One of the best examples is Revit, which began as an independent software startup in direct competition with AutoCAD and Autodesk in 2001, 2002, and we remember clearly Autodesk people coming and proposing software at Georgia Tech in a bigger research project in 2001. 2002, Gong Li was there and remembers that. And they claimed that AutoCAD was everything and Revit was rubbish and it was nothing. And a week later, they announced their acquisition of Revit for $128 million. So something in what they were saying was not quite right. So let's try to trace in a few words this idea of from research to startup and then sometimes to success and sometimes even to failure. My PhD supervisor in the early 90s was Abraham Warshawski, and he had pioneered a stream of research that dealt with robotics in building construction. What you're seeing here is a paper from 1985 in the Journal of Construction Engineering and Management. And at that time, they had these ideas of very generic robotics that could be done for various wall systems or other systems, things like this. And they worked at Carnegie Mellon during a sabbatical on different configurations. And the interesting thing about this is that they then, in the following years, built prototypes of construction robots of this kind, none of which succeeded. And the challenge of this became that these were too sophisticated machines, and were far too expensive to set up and maintain, and they could improve productivity, but the overall picture was such that they were not suitable and not economical for construction sites. And yet today, we see things like this. Okibo is a startup company, again, at home in Tel Aviv, and their idea is fairly straightforward. All they're doing is plastering, rendering on walls. And so they are sophisticated machines, and although this is just a rendering, this is just a quick video, the idea of using technologies that we have available now and become much more practical. I apologize for the music. We'll suffer the music for 10 seconds. But you get the idea that nowadays some of these tools have become a lot more practical. Another example is from some of our work. In 2006, we did this piece of work where we used from Liebherr construction cranes with a black box that was monitoring every movement of every part of the crane, and the data was there. The monitoring of the data was there. It was just a question of can you exploit it. And today, there's this company, Versatile Natures, who are doing exactly that. They have this special hook, and within the hook black box, they have They have a great variety of sensors of different kinds, and then that allows them to generate data about what the crane is doing, how it's doing, where it's going, how it's working, which then allows them to build up intelligence about what's happening on the construction site. So you have information about when different activities are done, and using some fairly simple machine learning, they can interpret what's actually being done on the site during those times. And then you see, for example, 2 weeks of activity where every day you have the quantity of crane use, what it's being used for, including the time spent traveling and the time spent waiting, which then gives you a sense of whether your lean construction efforts on the construction site are working or not. And these are the kinds of analytics of dashboards that we've never had available in construction, but they are now becoming fairly common. So there you have a digital twin of the crane. There is another company which I'm not showing here called Insight, which has now developed an entirely autonomous tower crane and mobile crane, so that you then get the operation as well feeding in. Here is another piece of work that we did a good 10 years ago, maybe a little bit more, where the idea was to say, can we create interfaces for construction managers where they have an image or a BIM model of the building, and overlaid on that a sense of what we call situational awareness. And so the idea is that if everyone on the job site and everyone in the supply chain has a sense of what's going on in the building at any one time, then they can make their own planning decisions with much more information and much more reliably. So you see here, for example, a painter might know what the situation is for their tasks and where they need to bring resources and where they don't. But that, from a research prototype, and this was just a mock-up, but that then led to a research prototype, which I'll show you in a moment. The general idea here is to merge lean construction and building information modeling. So Kanban from lean and BIM as BIM. So the prototype system was called CanBIM. And the software prototype itself in a research lab looked like this. So again, you could manipulate and move around the BIM model in any way, and you could know from these different tickets and labels what tasks were ready, what were mature, what could be done, what couldn't be done, and what was being done. It was delivered on laptops or on big touch screens on site, because in 2011 we didn't have all the mobile devices that we have now, which made the solution great in theory, works in terms of technology, but it's not accessible to people. And the big change, of course, that's happened is that now we have tablets and phones and a range of mobile devices, and so it's now become a commercial software called VisiLean, which is now spreading quite well and quite quickly. The idea being that it merges the BIM model with the construction scheduling and the ability for people to work with that day by day as they report what's going on, they learn what's happening. Situational awareness of supervisors, of construction workers, of supply chain, of deliveries, etc. is complete, so that they're all tuned into what's happening, and the last planner system is done online. Another simple image showing how this works. My point in showing you these different ideas is that all of them, the robotics and the crane monitoring, the construction management service, which is a software as a service, all of them began as research projects 15 to 20 years before they actually began to be possible as commercial implementations. And of course there are many, many more. Here is another one that's a little bit more practical. So you know that we spend a lot of time doing this kind of layout with chalk lines. Nowadays it's done with a robotic total station, which you then shoot points onto the floor. But in many of the trades, the points on the floor are not enough. Once you have the points, you need then to come and put in the lines between the points, which takes quite some time. And in lots of sites and lots of trades, you then have to transfer those lines onto the ceiling, because the floor is going to be occupied by materials, the chalk lines are going to be removed, the points themselves are going to be erased, so that once you have it on the ceiling, you have a reliable map, and then you begin working down the drywalls, the tracks, the MEP, and everything else. So again, we had this notion that, well, people have used AR, augmented reality, and indeed you see a DACRI smart helmet at the top and HoloLens on the left, the total station on the bottom right. And those are technologies that people have developed and become useful. As I said, DACRI is now no longer there. But the challenge with all of those is that you encumber people with equipment, which is difficult when you're doing your job. So we said, well, how about we do this? How about we project the BIM model directly onto the building itself? So people don't have to have anything, not wear anything. And a research prototype. It's, in terms of research, it was only published recently, but this began 4 or 5 years ago. And the idea was like this, that in terms of research, you can take a tripod, a small laser scanner, a camera, and a projector, and mount them together. They work together to do the localization and the positioning, and then project whatever it is, in this case a bathroom, onto the work surface, so that you then know what to do and where to do it. This was picked up by a company called Innovatice, again in Tel Aviv, and their idea is exactly the same: deliver work product and process information. In other words, you don't only project the lines, but you also can project text and codes and suggestions of how the work should be done. You also then, because it's mounted in the tool that they have built, there is a laser scanner. You can also at the same time monitor what's being done and then provide feedback. So you're essentially telling people, as you see here, where to do things, and as they do it, you're monitoring and telling them by voice, it's in the right place, it's in the wrong place, and then confirming that it was done back into the monitoring system. This is a slide photograph from a month ago at a construction site in London, where the equipment is still in a beta system, but it's already working and showing how to projecting the lines onto the floor, and so it makes construction much easier. You can project on the floor, on the ceiling, wherever you like, of course, on the walls. Which brings me to this, which is to say, what really is happening here? How is this innovation being introduced? And it has, I think, some foundations in theory, design theory, information theory, and lean production. I mean, in terms of construction, right? Design construction theory, how things are designed, how they're made. Information theory about how the information flows. And lean production theory, meaning if we understand correctly on a theoretical level how production flows in construction, all of those understanding, together with the BIM technology, which is, of course, not only the technology, but the processes and the people, the BIM way of working, if you like. If we have that foundation, then people can come along and innovate. So there's technology, there are business process needs, we need to improve construction, and there's entrepreneurship, mainly meaning risk-taking, or a willingness to put up capital and take risk and have new ideas. And if we have those, we can have ideas, investment, implementation, and if that works, then the survivors on that level move up to the implementation in construction. And that appears to be a path that is working for a great number of companies around the world. And it's a level of innovation in construction that I think we've never seen at quite the intensity that's been happening over the last, let's say, 5 years. We've all heard of the big companies like Katera and the others, but there are hundreds of others who are introducing a very wide array of innovations. This just gives you some of them. Katera, Procore, and Uptake are the three that they picked out as the key ones that have raised much more capital than the others. But as you can see, collaboration software, offsite management, offsite construction, project management, mobile cloud, and all the rest. Drones and aerial intelligence, building materials, robotics are the ones that are a little bit more hands-on in terms of building on the construction site. So we even see this now in digital twins. So you can have a look around in the internet and visit companies. And I was able to pick out just 5 companies, some more traditional startups, some less traditional startups, but nevertheless, they all share the activity within the area of digital twins. There's a company called Tunnelware, where they are creating images and digital twin models of the geometry of tunnels, but then they're collecting all the maintenance information and all the rest to go along and to present it to the maintainers of such tunnels, how these things work. A similar one called Willow, headquartered in Australia. Dynamic Infrastructure, another Israeli startup, where again it's tunnels and bridges, and it's about creating models very similar to those that Ilka showed us this morning, where you are collecting the images but then continuing to maintain the database behind, and they offer it simply as a software as a service with the whole database service, so to speak, a one-stop shop. I learned recently that Siemens are very active in this area, and Herman might, I don't know if there's an opportunity to explain more, but we've learned a great deal about your work and how especially the property graphs and the knowledge graphs are being used to create a layer of information that brings in information from all the monitoring and all the 3D models to create a platform on which API then you can build all sorts of use case applications. And I would be remiss if I didn't mention in this very good community Lock Lab as well, whom we saw this morning doing really wonderful things in terms of bringing technology to companies. I think, and you'll correct me if I'm wrong, but the service mainly being to provide the visual and digital model, geometry model, where the backbone of the information about the systems is maintained by the client rather than by the service. So it's a slightly different business model. But nevertheless, the interesting thing here is the degree of innovation that these guys have achieved is much more than any of these much bigger companies, whether it be Deutsche Bahn or anybody else, has achieved over very many years. So, here are some propositions that I would hope will spark your thinking, so that in the brainstorm session you might want to think about trying to answer some of these. What are the possible pathways for adoption of digital twins technologies and practices, not only technology, but also behaviors and practices in the built environment? And these are not the answers, but they're just some propositions that you might consider. Well, construction tech has largely followed these paths to adoption: academic research, and then startup implementation, but then established vendor acquires the startup. And sometimes that acquirer will be acquired in and of itself, which is why we have these very big companies, 4 or 5 big companies in the BIM digital construction area, who have slowly swallowed up a lot of the innovators in order to bring that innovation into their own arena. And that seems to be a repetitive pattern with many of those happening. I guess the difference between BIM on the one hand and digital twins on the other hand is this. The value of BIM is in the software and in the process, in the behaviors. So BIM processes are delivered mostly through private architecture and engineering consultancies. Whatever the client may be, the use of software like Revit and Allplan and others is by the professionals, giving a service to the bigger companies. So that for the vendor companies, the Autodecks and Nemetscheks and Bentleys and Trimbles of the world, the value for them is in selling software subscriptions, and that really is the core business model. On the other hand, digital twins is quite different. The value is in the information itself and the ways that I can use that information. So digital twin vendors, it appears to be that the way to get value is to generate the models to begin with, then organize the information and make the information accessible. You're not selling software, you're not selling a product, but rather a service which is very much related to the value of the information. And that suggests quite a different business model from those of the big software vendors. I'll say this, and there is a text prepared that I assume will be distributed or made available to everyone as well. And in the text, this is a brief part of it, but I just want to make these points. I think that there are 3 factors that will shape the business models. The first one has to do with the fact that because it's the information, because the information relates to big infrastructure systems, the real value is available, and it's only really the bigger clients that can mobilize the information in the beginning to have value. And so obviously, the low-hanging fruit for vendors must be the bigger clients to begin with. Second thing, digital twin vendors can generate value by generating, organizing, and making information accessible, the point I made in the previous slide. And another important point, it turns out that compiling the models is not something that the staff of these big organizations can do. None of them are geared to do that. And so the service of compiling the models is compiling and maintaining the models is something that service providers can do. And again, it's a service, it's not a product. So what industry business models are needed? Well, it seems that there are two key things that we can do as a service. We can compile models and we can curate models. Compile information and curate information. And so those need to be the key drivers of whatever business model we're going to put together. And finally, how should such models be introduced or promoted? Well, I won't surprise you by telling you that I think that startup companies will be more successful in innovating in this area than will be much bigger vendors. Of course, there's innovation within bigger companies, but generally it's smaller units which are innovating. But mostly it will come from others who are outside, who are able to do what they like with freedom to innovate and not necessarily be restricted by either legacy software within the company, legacy hardware within the company, or even standards of various kinds. Technology vendors that offer building or infrastructure operation software and hardware may be another opportunity, if not, or in parallel to startups, because if you are selling sensors of various kinds, and if you are selling building operations software, then clearly you could leverage this up to a higher level, and I think that's very much the model that Berit showed us this morning. One of the questions that was posed in framing the workshop that we're all attending was this: what level of maturity should digital twin tech achieve before it can be attractive to industry? And I think that we've seen enough over the last 2 days, even, and perhaps our previous experience will tell us that actually we should switch the question around. That in fact it may be that a lot of the technology is already there. A lot of it's been invented, clearly there's more to improve, but a lot of technology is there. And so it may be better to reframe the question this way. What level of maturity should building and infrastructure owners and or operators achieve in order for them to generate value from operation of their assets using digital twins? And that poses quite a challenge to anyone building a business in this scope, because there have been numerous businesses in the construction tech and construction area software who have come up with brilliant ideas about how to do things, but have found that the new ideas of how to manage things make a break with traditional ways of doing things, and the challenge of educating an industry to do things some other way, which can then benefit from whatever technology or software they're using, is a challenge that requires a lot of money, a lot of time, a lot of effort, and sometimes may in fact bring the business to fail. I can think of software like Outplan from a very good American construction company called BPR, which in the end died because they were not able to maintain the level of service to their clients to not only support them with the software, but explain to them what the paradigm for construction management was that sat behind that. So maybe there's a lot to be done in terms of education, publicity, and so forth. And finally, really what I'm saying is that potential clients need a degree of sophistication and the control of their assets that make it worthwhile, make them able to derive the value from using the digital twins. So given that large organizations are by nature difficult to change, especially with regard to sophisticated technology, this appears to be a bigger challenge than the question of maturity of the technology itself. And with that, I will stop and open for questions or discussion. I don't have any answers particularly, so we'll transfer the questions to the brainstorm later.
I have a question about the education element, your last slide. 7 years ago, when my daughter was 1 year old, she was able to pick up my smartphone at the time, unlock it without me telling her the password, firing her favorite Peppa Pig app and start playing. Now, why is that possible? Because clearly the company who developed the software behind it put in enough research into user requirements and usability and so on to make a phone that even a 1 year old can use it to that level. By contrast, we have, in my view, a very, I can't imagine how terrible of a word I can use to label all of our big companies in that sector when it comes to the education front, about the propaganda of needing more education to use their software. Yes, because it's crap. All right? We need to write, even at the education level, we need to write tutorials to teach our students how to install Revit. Right? Can you imagine anyone giving a tutorial of how to use a smartphone? Right? We have some terrible software systems, and the companies, instead of admitting that it's terrible, they're telling you, oh, no, you need more education. To me, that's 1980s thinking, when the designer was the professional that had to go through loads and loads of training to even be barely productive. We are past that now. We are beyond the millennial generation. Yeah, right. I think we need to move, and this is why I disagree with reversing the argument, because the argument takes on the responsibility from those who are creating those systems and places it on the owner. I understand the owners do have some responsibility, but I still think the bigger responsibility is with those who make the software.
I won't for a moment claim that all the software we have available has wonderful user interfaces. It doesn't. Clearly there's more to improve. But that's not what this is about. What this is about is changing business models. It's changing ways of working. We know that in structural engineering companies, the introduction of AI and learning is already changing the way they work. So that many structural engineers will be out of jobs. Using digital twins to run your railway or your building is quite different from anything you've been doing up to now. Playing Miss Piggy on the phone is not necessarily different from reading a book or doing something else. I mean, it's not a fundamental way of changing how kids play. But these are more fundamental changes of how people run very big businesses with very big infrastructure systems. And that's not trivial. It's not just about the software. Would be my counter argument. Yeah.
Thank you, Rafael, for the talk. You showed this slide with the 3 pillars and the foundation and innovation, etc. In your personal view, yeah, this one, thank you. Which of the piles, in the theory piles, do you think is the weakest?
That's a great question. I can't say which is the weakest, but I could comment more generally. I think that our understanding of how we perform design is not very strong. There have been some really interesting works which deal with the philosophy of design and how design is done. And I'm speaking specifically about the construction industry. More recently, which are very enlightening, especially because what the software and the technology and building processes are doing is they're allowing us over time, and I think it will increase, they allow us to do simulations much more quickly. We still have a lot of problems with interoperability, so the cycles of iteration, for example, between architect and structural engineer are still fairly long, but they're shorter than they used to be. But if we crack the interoperability problem a little better, those cycles will become much shorter. And I think that will enable much more collaborative design, what we've been calling concurrent design or collaborative. Those things are still very difficult, but they will become more possible. And there will be a lot more automatic tools. So the nature of design we need to understand. Lean production theory is something I'm much more familiar with, of course, but there I think we have a very clear idea of how things work. It's just quite hard to get your head around. And most construction companies don't really engage with the ideas of flow and of production that could make their work a lot better. Not to say there's not more to do. There's not more to do. Information theory, I guess, is the area I'm least familiar with, and so I'm not going to comment there. But I think that there is enough in all those three for people who are engaged in investing in startups or starting their own startups to have a better idea how all these things work, and it will help us understand what might succeed and what is destined to fail from a much earlier stage.
But I would prefer your foundation to have production theory, not lean production theory.
Well, that's fine.
Not pattern production theory.
Well, you can say construction production theory would be better. I agree.
I like your model here. I wonder, with the theory tiles, whether there's also something to do with change theory and decision theory as being important. Change theory because of the need for people to do something in this. It's not just a technological issue. And decision theory because I have a feeling that when we serve up much better insight from the wonderful twins that we're going to be producing, there's going to be a whole bunch of people who are going to struggle to change the way they make decisions. And really understanding how decisions are made and what optimises decisions, and when we should wait for more information and when we shouldn't, all of that kind of stuff I feel is another one of those theory foundations.
Yeah, transformational organization theory. I take the point. Absolutely.
Okay, thank you, Rafael, for a very good talk, very thought-provoking. Now we come from